Hey everyone, welcome back to another video. So this video is going to be about AI engineering. So everything about AI engineering, how it differs from software engineering, how it differs from machine learning or data scientists, and what are the skills you need to become an AI engineer? What are the common myths about AI engineering? What would you need to crack AI engineering interviews? And finally, I'll also share resources on how to learn and how to go about learning AI engineering so that you can be one too. Let's get right into it. Now, before we begin, let's go through what we will be covering in this video so that you have a clear picture of what's going to be talked about, and you feel free to skip to the relevant chapter if you worry about any single of the points mentioned here. So this video largely covers what AI engineering is, how it is different from software engineering, how is it different from ML engineers or data science professionals, and common question everyone has: what do AI engineers build in companies or in production at the current moment? Now it's almost end of 2025. What are the core skills needed? Is it full stack, backend, ML, data science? What do you really need? And also common myths and mistakes, how to learn AI engineering step by step. Also share some resources which will be very useful, something like a roadmap, how AI engineering interviews work in the UK, but I'm sure it should be similar globally as well. How do you practice and get interview ready? Let's jump right into our first topic. So, what is AI engineering? AI engineering simply means building products or prototypes powered by AI. Now, it can be a fully functioning P, or it can be something like a microservice which is exposed to another app, or multiple services. Now, it focuses a lot on systems, so it's more related to software engineering. Now, it can be research, but it really depends from companies to companies. Some companies have research teams, or also called as pilot teams, because currently we do not know how many projects it can take over or how many Ps can be built. So there's a lot of research going on. Can it be successful? Are the results good? Are they useful? Is the reasoning good? Is the thinking of the model good? So there's a lot of questions around that. So you'll see a lot of pilot projects going around for sure, but it definitely focuses a lot more on the system side rather than the data science side. Now, engineers use multiple models. So they have, let's say you work on a agentic framework, you will end up using multiple models, testing your performance or your app's performance, or using multiple models, evaluating them, and making sure that they are the output what you expect. Fine tuning is optional, just because these LLMs are getting very good day by day. So ideally, I've not had a use case where I had to fine tune, but I do not close that option too. There might be some fine tuning involved, but ideally, or at least 75% or 80% of the use cases, you would use a model which is already out there. Now, the last is you would be shipping AI that is to real users, which is users will be using the products which have LLMs, or which have reasoning systems, which have agentic systems, which have workflows. So there's quite a lot of these different ways or different parts where AI engineering is applied. We'll talk about them in some time.
Let's now see the difference between AI engineering and software engineering. Software engineering is extremely deterministic. There are clear rules and there is clear logic. The code is either correct or incorrect. But AI engineering involves a lot of probabilities and behavior. Now, this is quite related to the way you put your prompts, the model you use, your agentic engineering. So, the way you engineer all these things can heavily differentiate your outputs. Hence, that's the reason why the outputs of AI engineering or AI products are heavily evaluated. They're not perfect, but they are always tried to tune, or engineers always try to tune their outputs to near perfect. It's more or less like you have about 10 screws. It's about finding the correct tightness of each screw so that you get the best output. That's the simplest way to put it. Let's talk about AI engineering and data science. Now, this definitely varies from company to company. Some companies have their AI engineers and data science people sitting parallelly or sitting together in the same team. One does a lot of research, training, the other makes the research which is done by a data scientist into a full platform or a full software or a product. The ML guys focus on experiments, a lot of accuracy, loss functions, and results from the models. But the AI engineers focus on reliability. In case the AI engineer is a full stack, he or she focuses a lot on product building and the output evaluation, the agentic engineering part of the system, and also the system design of the system. What do AI engineers actually build? So these are a few examples: chat system, chatbots, assistant features, any search or Q&A systems, FAQ systems, any AI APIs or services exposed as a microservice so that multiple products or services can consume those API or services. The final one is automation workflows for literally anything by using an LLM, reasoning agents. And again, it completely depends. Is it a workflow? Is it an agentic automation? So there's so many or different varieties of all these. Now these are only a few examples. I'm sure there's a whole list of these what AI engineers can definitely do, and this is the reason they are quite in demand in 2025. So the core skills needed to become an AI engineer: Python or TypeScript. Most agentic frameworks are in either of the languages, Python or TypeScript, because they are quite popular in 2025. And a little about the AI side of things. What's an embedding? Vector DB. RAG is another one, which is retrieval augmented generation. Agentic frameworks like LangChain, LangGraph. You should know to build quite robust APIs and backends. Any business logics is going to be there. And you're going to expose any route through an API. You have to be good at prompt writing. There's quite a lot of different ways to write a prompt: one shot, few shot, chain of thought. Those are few examples, but there's multiple techniques to write prompts. You should know how to handle failures, any fallback strategies for any AI engineering work you do. And the most important one is you should be able to measure your output quality. I know there are frameworks like Langsmith which help you, or which is coupled directly with your LangChain and LangGraph. That's quite useful there as well. Now, apart from these, you definitely need a lot of system engineering skills, system design, agentic engineering, which is building out your agents. There's quite a lot of patterns for building agents. There's different ways to do it. We will talk about them later in a separate video, but those would be the core skills needed. Now, talking about common mistakes and myths, you definitely don't need deep mathematics as a quantitative developer. You may not need to fine tune models. So again, it really depends. Currently, I've not fine tuned any model as far as I've worked. I've been working on them for a year and a half. So I've only had to use a lot of the LLMs and to create agentic workflows, but I've not had to train my own model. Now, copying demo projects is something I see many beginners making. The problem with that is every use case is just unique by its own. The data workflow, it might be very specific. So if you copy a public project out there, it's not going to help you very much. You have to know what you want to tweak and where you want to tweak so that you get the best output. Another mistake I see is ignoring any edge cases. Edge cases are the most important thing in AI engineering, and how your edge cases are handled by the system you're building is extremely important. The other mistake I see people making is you definitely have to think about your users. You have to think, how are they going to use this? What's the workflow going to be like? And also about latency and performance. How much time is the user going to wait before he or she wants to see a response? So that directly translates to, what do you have to parallelize? What things can be background jobs? How can you speed things up? And also caching strategies come in. So there's a lot of things that come in just when you start thinking about users. So you should always look at it from their point of view, which will help. So how to learn AI engineering? The best is to start with where you are at the moment. Are you a backend dev? Are you a full stack dev? Are you a data scientist or an ML engineer? Are you working towards building products with AI? So that is where you should focus. For the AI engineer roadmap, I would follow the roadmap.sh engineer roadmap. It definitely is quite useful. It gives you a good roadmap starting from basics. If you don't understand anything, you should just go into a topic and it'll give you all the resources and the explanation. So something which is very good and I find useful as well. You should build something. Proof of work has been extremely important going into 2026. You should add AI into any apps you already have or you have already built, or build an AI app from scratch. That would help. You should spend some time learning system design. I personally prefer Byte Go or Alex Zhu, who has two books, two volumes, explaining system design and creating different systems and designing different systems. So that's definitely useful. Data structures are quite important because if you have a coding round or a live programming, pair programming, you're expected to share your screen and then code right in front of the interviewer. So data structures is quite important. So most common problems I've seen are in arrays, strings, sliding windows, pointer problems. You should know to code them, figure the pattern out, and then determine the time complexity and the space complexity. So I would recommend that you keep building real projects, be it small project. It can even solve one small thing, and you make that product out of AI. That'll be something great. You definitely debug through systems. You monitor your AI usage, your prompts, and you continuously version your prompts so that you get the best results out of the system. And the last one is you have to be good at explaining why you chose something over the other. And that definitely helps because it helps you support your arguments while also providing explanations for them. So, how interviews work for AI engineering? They are more similar to software engineering, but the only difference they have is they check your AI experience, what you have built with AI, what you have designed with AI, and how you have monitored your AI responses. And you should make sure that you communicate extremely clearly throughout the interview, regardless of the round. So, how do you practice? So, as I mentioned, you should build an AI app, put it on your GitHub, talk to more AI engineers, see what they're building, go on Threads, go on X, go on YouTube, have a look what apps are being built. You have to be good at practicing your coding skills and also your system design. So make sure you go through it and you know why you're choosing one over the other. You should, in your interviews, make sure you get good feedback, keep improving, keep learning. And if you have any questions, let me know down in the comments. I will answer as many questions as I can. I hope you learned something new today. I wish you all the best in your learning journey.